It is also possible to mathematically prove that the moon orbits the Earth without rotating by using the following calculations. We know that one orbit is equal to 360 degrees. If we assume that the moon is making 1.5 rotations per orbit, then 360 divided by 1.5 is equal to 240 degrees, which means that the moon should complete one full rotation by the time it reaches 240 degrees in its orbital path and the remaining 0.5 rotation at the end of the orbit. If we assume that the moon is making 1.001 rotations per orbit, then 360 divided by 1.001 is equal to 359.64 degrees, which means that the moon should complete one full rotation by the time it reaches 359.64 degrees in its orbital path and the remaining 1,000th of a rotation at the end of the orbit. If the moon is making 0.999 rotation per orbit, then 360 by 0.999 is equal to 360.36 degrees, which means that the moon will now complete one full rotation after it has completed one full orbit and then advanced by 0.36 degrees in its second orbit. In both these instances, the entire moon surface will be visible from the Earth. Since this is the only way that the mathematical results can be interpreted and experiments conducted accordingly, it is not only logical but also absolutely imperative that when the moon makes one exact rotation per orbit, its rotation has to be shown in this manner only. Otherwise, we will be contradicting mathematics. What is good for the goose must also be good for the gander. Since the entire moon surface will be visible when it makes 1.001 and 0.999 rotations per orbit, rationally speaking, it should be visible when it makes one exact rotation per orbit also. It is also now clear that as long as the moon is rotating, even if it is by just 1/100th of a rotation per orbit, its entire surface will still be visible from the Earth in the course of it completing 100 orbits around the Earth.